Hello and welcome to CET 4884 Security Methods and Practice. In this session, we will continue our discussion on firewalls through understanding their architecture. In addition, we will learn how to select the proper firewall, configure it, and manage it. We will address the remote access concept, and we will also address virtual private networks. When selecting the best firewall for an organization, you should consider several factors. The most important of these is the extent to which the firewall design provides the desired protection. What type of firewall technology offers the right balance between protection and cost for the needs of the organization? What features are included in the base price? And what features are available at extra price? Are all cost factors known? Those are the type of questions that you need to ask the vendor to know exactly what comes with the firewall, because most likely you will have certain features that will be basic, and then you will have extra features that you need to pay for. You can also ask how easy is it to set up and configure the firewall. How accessible are the staff technicians who can competently configure the firewall? Could someone or could a technician do it? Is it going to be easy for the technician to do it, or do I need to train them to do it? Can the candidate firewall adapt to the growing network in the target organization? What if we are extending our organization? Would the firewall be able to adapt to that growing? The second most important issue to consider is, of course, the cost of that firewall. Good policy and practice dictates that each firewall device, whether a filtering router, bastion host, or other firewall implementation, must have its own set of configuration rules that regulate its actions. The configuration of firewall policies can be complex and difficult. Configuring firewall policies is as much an art as science. Each configuration rule must be carefully crafted, debugged, tested, and sorted. When configuring firewalls, keep one thing in your mind. When security rules conflict with the performance of the business, security often loses. So you need to know that the upper management will concentrate on the performance of the business, on the efficiency of the business. So most likely you will, if you want to argue as security personnel, you will lose if it comes to security. Performance in the business is more important than security, unfortunately. The best practices for firewalls is to configure those firewalls where all traffic from the trusted network is allowed out. The firewall device is never directly accessible from the public network to prevent any intruders from changing the firewall policies. Simple mail transport protocol data is allowed to pass through the firewall, but should be routed to a well-configured SMTP gateway to filter and route messages or messaging traffic securely. Any trusted email message will be sent to any untrusted email message will be sent to junk mail. All internet control message protocols data should be denied. Telnet access to all internal services or servers from the public networks should be blocked. When web services are offered outside the firewall, HTTP traffic should be denied from reaching your internal networks through the use of some form of proxy access or DMZ architecture. So usually this is what we set up our firewalls to do. Those are the best practices. you need to know how to configure it. You need to know how to set it up in a way to allow outgoing flow of traffic, but try to filter and protect whatever comes to the network or is trying to access the network. Firewall or firewalls in general operate by examining a data packet and performing a comparison with some of the predetermined logical rules. This logical set is most commonly referred to as firewall rules, rule base, or firewall logic. Most firewalls use packet header information to determine whether a specific packet should be allowed to pass through or should be dropped. This figure shows an example of a good network configuration, and you can see that we have more than one layer to make sure that nothing will pass through unless it's really secured. And if anything that we need to share with the outside world, then we can do it through the DMZ, the demilitarized zone. That's where they can access the web server, they can access any other services, including the email, the SMTP, and after that everything will be filtered to go inside the trusted network. The table on this slide shows firewall commonly known port numbers and their use. So those are the port numbers that usually used, and those are the protocols that we use it for. The table on this slide shows a recommended rule set for external filtering firewall inbound interface. Note that the rule allowing responses to internal communications comes first, followed by the 4 rules prohibiting direct communications to or from the firewall. After this comes the rule stating that all outgoing internal communications are allowed, followed by the rules governing access to the SMTP server and denial of ping, telnets access, and access to the HTTP server. If heavy traffic to the HTTP server is expected, move the HTTP server rule closer to the top, for example into the position of rule number 2, which would expedite rule processing for external communications. The final rule in the table denies any other types of communications. The table on this slide shows recommended rule set for external filtering firewall outbound interface. Note the similarities and differences in the two rule set. The internal filtering router firewall rule set shown in outbound has to both protect against traffic and allow traffic from the internal network, the 192.168.2.0. Most of the rules in the table are similar to those in table 6.16, allowing responses to internal communications, and that's rule number 1. Denying communications to from the firewall itself, that's rule number 2 through 5. And allowing all outbound internal traffic, that's rule number 6. Note that there is no permissible traffic from the DMZ systems except as in rule number 1. Why isn't there a comparable rule for the 192.168.2.1 subnet? Because this is an unroutable network. External communications are handled by the NAT server, which maps internal 192.168.2.0 that addresses to external 10.10.10.0 addresses. This prevents a hacker from compromising one of the internal boxes and accessing the internal network with it. The exception is the proxy server, rule number 7 in table 617, which should be very carefully configured if the organization does not need the proxy server, as in case where all externally accessible services are provided from machines in the DMZ, then rule number 7 is not needed. Note that there are no ping and telnet rules in table 617. This is because the external firewall filters these external requests out. The last rule, rule number 8, provides the cleanup for these traffic data bits or data bytes. Content filter is a software filter, technically not a firewall, that allows administrators to restrict access to content from within a network. It's essentially a set of scripts or programs that restricts users or user access to certain networking protocols and internet locations, or restricts users from receiving general types of specific examples of internet content. Some refer to content filters as reverse firewalls, as their primary focus is to restrict internal access to external material. In most common implementation models, the content filter has two components, rating and filtering. The rating is like a set of firewall rules for websites and is common in residential content filters. The filtering is a method used to restrict specific access requests to the identified resources, which may be the websites, servers, or whatever resources the content filter administrator configures. The most common content filters restrict users from accessing websites with obvious non-business related material, such as pornography, or deny incoming spam email. Installing internet work connections requires using leased lines or other data channels provided by common carriers, and therefore these connections are usually permanent and secured under the requirements of a formal service agreement. In the past, organizations provided remote connections exclusively through dial-up services like remote authentication services, the RAS. Since the internet has become more widespread in recent years, other options such as virtual private networks, VPNs, have become more popular. Dial-up is a widely held view that was unsecured. Dial-up connections points represent a substantial exposure to attack. An attacker who suspects that an organization has a dial-up line can use a device called a word dialer to locate the connection points. A word dialer is an automated phone dialing program that dials every number in a configured range and checks to see if the person answering a machine or modem picks up. Some technologies such as radius systems or TACACS and Ch6 password systems have improved the authentication process, and you can see now there are many options in the authentication just to make sure that no one can access other people's information. Radius and TACACS are systems that authenticate the credentials of users who are trying to access organization's network via a dial-up connection. The remote authentication dial-up or dial-in user services or service system places the responsibility for authenticating each user in the central Radius server. When a remote access server receives a request for a network connection from a dial-up client, it passes the request along with the user's credentials to the Radius server, which then validates the credentials and passes the resulting decision, accept or deny, back to the accepting RAS. Similar in function to the Radius systems or system is the terminal access controller. The terminal access controller access control system, which is the TACS, like Radius, is an centralized database and validate the user's credentials at this server. The diameter is an emerging alternative devices from Radius. This figure shows the Radius configuration, and you can see how or what are the steps that will be used just to make sure of the authentication of the user or the authorization of the user. Kerberos can be used to secure authentication also. Kerberos uses systematic key encryption to validate an individual user to various network resources. Kerberos keeps a database containing the private keys of clients and servers. In the case of a client, this key is simply the client's encrypted password. The Kerberos system knows these private keys and can authenticate one network node, client or server to another. The Kerberos consists of 3 interacting services, all of which use database library. The first one is the authentication server, or AS, which is a Kerberos server that authenticates client and servers. The second one is the key distribution center, or KDC, which generates and issue session keys. And the third one is the Kerberos ticket granting services, or TGS, which provides tickets to clients who request services. In Kerberos, a ticket is an identification card for a particular client that verifies to the server that the client is requesting services and that the client is a valid member of the Kerberos system and therefore authorized to receive services. The ticket consists of the client's name and network address, ticket validation starting and ending time, and the session key, all encrypted in the private key of the server from which the client is requesting services. This figure shows the Kerberos login and the authentication process and how it works. This figure shows the Kerberos request for services and to make sure that the person who's asking for authentication or authorization to get access to the material they need if they are authorized. The Secure European System for Application in a Multi-Vendor Environment, which is the SAME or SAME, is similar to Kerberos in that the user is first authenticated to an authentication server and services or receives a token. The token is then presented to a privilege attribute server instead of the ticket granting services or service as in Kerberos. And this token will be as a proof of identity to gain a privilege attribute certificate or PAC to access the material or the files that will be required. The SAME also builds on the Kerberos model by adding additional and more sophisticated access control features, more scalable encryption systems, as well as improved manageability, auditing features, and the delegation of responsibility for allowing access. The virtual private networks, which is now it's spreading and everybody's using VPNs, is especially with the pandemic and the way that you need to access material remotely, is a private and secure network connection between systems that use the data communication capability of an unsecured and public network. VPNs are commonly used to extend securely an organization internal network connections to remote locations beyond the trusted network. The VPNC defines three VPN technologies. The trusted VPN or VPN uses leased circuits from a service provider and conducts packet switching over these leased circuits. Secure VPNs use security protocols and encrypt traffic transmitted across unsecured public networks like the internet. And the hybrid VPN combines the two, providing encrypted transmissions as in secure VPN over some or all of the trusted or a trusted VPN network. A VPN that proposes to offer a secure and reliable capability while relying on public network or networks must address the encapsulation of incoming and outgoing data, where in the native protocol of the client is embedded within the frames of a protocol that can be routed over the public network, as well as be usable by the server network environment. And then we have the encryption of incoming and outgoing data to keep the data contents private while in transit over the public network, but usable by the client and server computers and or the local networks on both ends of the VPN connection. And then the authentication of the remote computer and perhaps the remote user as well. The authentication and the subsequent authorization of the user to perform specific actions are predicated actually on accurate and reliable identification of the remote system and or user. In transport mode, the data within an IP packet is encrypted, but the header information is not. This allows the user to establish a secure link directly with the remote host, encrypting only the data contents of the packet. There are two popular uses for transport modes VPNs. The end-to-end transport of the encrypted data. In this model, two end users can communicate directly, encrypting and decrypting their communications as needed. Each machine acts as the end node, VPN server, and client. A remote access worker or a teleworker connects to an office network over the internet by connecting to VPN server on the perimeter. This figure shows a transport mode VPN. In the tunnel mode, the organization establishes two parameters or parameter tunnel servers. These servers serve as the encryption points, encrypting all traffic that will traverse an unsecured network. In tunnel mode, the entire client packet is encrypted and added as the data portion of a packet addressed from one tunneling server and move it to the other. The receiving server decrypts the packet and sends it to the final address or final destination. The primary benefit to this model is that an encrypted or that an intercepted packet reveals nothing about the true destination system. This figure shows the tunnel mode VPN and how it works by sending the encrypted client packets and places as data in a packet addressed for the remote VPN server. So that will be all for this session. If you have any questions, please feel free to send me your questions, and I will be more than glad to answer it. Thank you and have a great day.